Here's another interesting word problem that was sent by Cortaggio. A woman cycles to work alongside a railroad track at 6 kilometers per hour. That's an interesting piece of data, 6 kilometers per hour. Every day she arrives at a crossing the same time that a train does. Okay? One day she was 50 minutes late and was overtaken by the train 6 kilometers from the crossing. And how many minutes will the train reach the crossing? So let's see if we can draw a diagram here that can somewhat describe what's going on in this problem. So what's on a normal day? On a normal day, she leaves from home. She leaves from home and she goes and she travels alongside a railroad track. Not too different than my own commute on my own bicycle. I actually do travel along a bike path that's right along a railroad track. Anyway, she leaves here. Let's say she leaves here at time is equal to 0. Time is equal to 0. And right at this point right here, maybe that's where the railroad crossing is, right there, the train passes her up. And she's traveling at 6 kilometers per hour. 6 kilometers per hour. 6 kilometers per hour. And what else does it tell us? It doesn't tell us how long it takes her or how far she travels. So let's just write. Let's just say, so let's say she arrives here at t is equal to a hours. T is equal to a. We'll do time in hours since we're in kilometers per hour. So this path takes her a hours to travel. So it takes her a hours. If we care about the time, a hours. Now, on this next day, she's 50 minutes late. So in this day, she has to travel the same distance in both distance and time. But this is this day. She leaves not at t equals 0. She leaves 50 minutes late. And since we're dealing with hours, let's write 50 minutes in hours. So she leaves at, if this was time equals 0, that's when she normally leaves. She's now leaving at time is equal to 50 minutes, or time is equal to 5/6 hours. Right? 50 minutes is just 50 over 60 hours, or 5/6 hours. So time is equal to 5 over 6 hours. This time is equal to 0 hours. And let's see, it says that she was overtaken by the train 6 kilometers from the crossing. So she was overtaken by the train, I don't know, someplace over here. And this distance, right here, this is where the crossing is. That's that crossing. This is 6 kilometers. 6 kilometers. And how many minutes will the train reach the crossing? So if we can figure out some way of expressing this time, if we can figure out what this time is, we know that the train reaches the crossing at t is equal to a. So if we know this time, we could just find the difference between these two times, and we would have solved the problem. So let's see if we can figure out this time. So we know that it normally takes her a hours to travel this whole distance. It doesn't matter when she leaves, it takes her a hours. So in this case, it should also take her a hours. And how long does she have to go when the train passes her up on this day that she was late? How long will it take her to go this distance right there? Well, she's traveling at 6 kilometers per hour. She has to go 6 kilometers. So in time, this is going to take her 1 hour. To get, the train will have long passed her, but to get back to the crossing, she's going to have to travel for another hour. So if her whole route takes her a hours, if this whole length and time is a hours, then this distance right here is going to have to take her what? She has an hour left. Her whole trip is going to be a hours, so this is going to be a minus 1 hours. Let me scroll down a little bit. This is going to take her a minus 1 hours. So if on the day she was late, it took her a minus 1 hours to get passed by the train, what time are we talking about right here? What time is this? This is t is equal to, well, we started at 5/6. T is equal to 5/6. That's where we started, plus the amount of hours she traveled, plus a minus 1. So there I think we now have all the information we need to solve this problem. On the day she's late, the train passes her at time is equal to 5/6 plus a minus 1 hours, where a is the amount of time it normally takes her to travel her entire route to the crossing. We know that the train passes this point at t is equal to a. So if we want to know how many minutes does it take the train to go from this point to this point, we just have to subtract the two times. So the minutes it takes, Well, the hours, because we're dealing in hours. Remember, I said 50 minutes was 5/6 of an hour. So the minutes it takes is that A, minus this, minus 5/6 plus A minus 1, right? That's just the difference in time for the train in hours. So this is A minus 5/6 minus A plus 1. Luckily, the A's cancel out. A is A minus A. And you're left with 1 minus 5/6 hours, which is just equal to 1/6 hours. There are 60 minutes in an hour, so 1/6 of that is 10 minutes. So it takes the train 10 minutes to get to the crossing from the point that it passed her. Another neat problem, and I thank Cortaggio for that. And then you could actually use this information if you want to figure out how fast the train is going, or you could even think of other types of kind of derivative problems off of this one. Anyway, another good problem.